Do you have something?
Yeah, so as far okay, so the server sends out the information to the other switches. So in that graph right there, let's say the transparent switch was set up as a client switch. How would it then pass on the information to the clients after if it's not a server?
Well, it still forwards the VTP advertisements from the server. It just doesn't send its own. So like if you had basically in this network here or whatever, if this was a client switch instead of a transparent switch, it would still forward these packets or these VTP advertisements like it's doing now, but it would also apply those changes to its own configuration or its own DAV file. And so we kind of touched on this a little bit. VTP pruning. By default, all VLAN traffic is sent over all trunks. But this can cause some excessive traffic if some VLANs don't even have any access ports on a particular switch. In these cases, specific VLANs can be pruned from specific trunks to cut down on unnecessary traffic. So I talked about that before. Let's say you have you've got this complex switched network, and in one particular closet somewhere you've got this one switch that has only got the engineering department on, so it's only got one particular VLAN on it. Well, you might not want to have that switch get bogged down by the broadcast and multicast advertisements from your other VLANs, your sales departments, your HR department, etc., etc. So you might want to prune off any VLANs that are not going to cross that. So in this case, if you've only got one VLAN there, you probably are going to prune off everything except for the management VLAN, VLAN 1, and the actual VLAN pertaining to that switch. That's VTP pruning. Okay, so configuring and verifying VLAN Trunking Protocol. Start by setting a VTP domain and MD5 password. It's important to set a domain and password because let's say someone randomly hooks up another switch to your network that's set for server mode. If you don't have a domain name and password set, or he's able to figure out what the domain name and password are set to, someone could potentially connect a switch, set it for a higher revision number than your current switch, and then basically propagate out changes that will eliminate all of your VLANs on the network because it would presume that that's the newest information. That being said, it's also important to make sure, before we get up totally into these configurations, if you're ever connecting a new switch, or especially if it's an old switch that you had tucked away somewhere, that you confirm the domain and password as well as the current revision number and whether it's set to server or client mode. The last thing you want to do is accidentally hook up an old switch on your network that's still configured for the same VTP domain and password that's got a higher revision number and eliminates all of the changes that you've got out there. So the actual configuration from global configuration mode on the switch, it's just VTP domain and then whatever the domain name is, in this case CCNA. And then to set the password, it's just VTP password and then whatever you want your password set to. And again, all of these values have to match on all of your switches, or it's going to assume that it's in a completely different VTP domain and kind of do its own thing. To change the VTP mode, again, server is the default mode. It's just VTP space mode and then whatever mode you want it to be. In this case, transparent. Also, server or client are obviously options as well. And then to verify VTP revision number, operating mode, domain name, pruning status, and MD5 digest, you can use the show VTP status. So that's what I was talking about. If you're going to try to throw some switch on that you haven't had connected to the network in a long time, you probably want to do a show VTP status and make sure it's set up correctly and it doesn't have a higher revision number than your switch network is already using. Okay, so now we move on to inter-VLAN routing. So we talked about this before, that the individual VLANs cannot communicate with each other without the use of either a layer 3 switch or a router. One method for getting VLANs to communicate with each other is known as a router on a stick configuration. This involves, and yes, that's actually the term. That's not just something I made up. Router on a stick. This involves connecting a router to a switch trunk and configuring multiple sub-interfaces on the physical router interface. Each of these virtual interfaces assigned to a logical gateway IP for each VLAN. It's a good practice to make each sub-interface number match the VLAN number, and to kind of add on to, well, Yeah, I guess I've actually got the configuration on here. So to add on to that, so like in this situation, you've got a switch network down here. You've got a couple different computers on different VLANs. You got a trunk running between the switches, and then you got a router up here that's got a trunk link going from this switch. So that trunk link is going to contain all the VLANs going on this switch to the router. So on the router, it's connected to port Fast Ethernet 0/1. Well, since you've got lots of different IP blocks for the various VLANs, configuring that for just Fast Ethernet 0/1 is only going to give you routing for one VLAN. But if you set sub interfaces, which would be like Fast Ethernet 0/1.1, .3, etc., you can set multiple IP addresses for each of those sub interfaces. So in this case, we've got VLAN 1, so interface Fast Ethernet 0/1.1, IP address 192.168.1.1. And remember, this is always going to be the gateway address for whatever that VLAN IP block is. Encapsulation .1Q1, one specifying the VLAN number again. And then, you can jump down into interface configuration mode for 0/1.3 to correspond to VLAN 3. The .1 and the .3 on the actual subinterface name, those do not identify the VLAN immediately. That's what you've got to have, this encapsulation .1Q and then whatever the VLAN number is. But it's a good practice to keep those as the same number. That way it's not super confusing if you're looking at the router configuration, trying to figure out what goes where. And then so on .3, configured as 192.168.3.1, and then for VLAN 3 down here. And you can do that for pretty much any number of VLANs. The other method of getting inter-VLAN routing set up is through switch virtual interfaces. This requires a layer 3 switch. Now, to me, I guess when I hear layer 3 switch, I assume, well, that's a router. And I guess in a way it is, but it doesn't have all of the functionality that a router might have. So layer 3 switches have routing functionality. So I guess technically they do route, they kind of are routers. But they actually also do it at the switching speed of ASICs. So there's little ASIC chips on there that make switching so quick. You basically get routing speed at switching speed. But they do lack some of the aspects of routers, like you're not going to have serial interfaces on a layer 3 switch. The other thing is layer 3 switches are very expensive if you ever go price them. I thought about getting one for practicing stuff for the CCNP and was quickly turned away when I saw the pricing, even on used stuff. Switch virtual interfaces are configured as VLAN interfaces on a layer 3 switch in the network to kind of set that up. So back to here, same kind of diagram, except in this case, this device up here is not a router. It's a layer 3 switch, but otherwise the configuration is the same, or the setup is the same. You've got two switches, VLAN 1, VLAN 3. You've got a trunk between here carrying all VLANs. You've got a trunk between here and the layer 3 switch connecting all VLANs. For the switch virtual interfaces, though, rather than setting up sub-interfaces for just that physical interface, you're actually going to configure interface VLAN 1, interface VLAN 3, etc., and assign IP addresses to those. So that's kind of the difference between setting up to a router on a stick and then setting up to a just layer 3 switch that can actually do some routing at switch speeds.